All right. Some folks are pretty experienced with this kind of stuff, maybe in venture crew or scouting or what have you. Some of you guys and gals have never used a compass before in your lives. Either way is okay. So, if you're not real sure what you're doing right now, sound off, happy to help. We're done when everybody gets across the finish line. Here's a tip. Buildings are not marked on this particular edition of this topo map, so we want to go with natural features instead. So the point at Thompson Point to different people could mean different things. Pick a specific point on Thompson Point at the shoreline that you're pretty sure you can spot it on the topo map as well, and shoot your azimuth to that, not to a big sort of amorphous blob of a thing. So with a little bit of practice, you can get almost as fast doing this as pulling out your GPS and waiting for the satellites to acquire and zooming in and loading the topo map layer behind your position and so forth. There's not really a right or wrong way to do this as long as you get to a correct position on the map. Electronically or with a paper map, no big deal. Competent foresters should be able to switch almost seamlessly between the two. All right, set it on the table, we'll talk through it. So the very normal question is, how do we even figure out generally where we are on the topo map? At this stage, we don't know. This is why we're doing this whole activity, okay? What we do need to be able to find are the landmarks on the map, okay? So the two lollipop loops on the northern center section of your map, those are the roads over on Thompson Point. That's this spit of land directly ahead of us and slightly to the right as we're facing out this gap in the vegetation. So the Thompson Point buildings are just outside of each of those lollipop loops. You could pick a point of interest or landmark on the near side of those roads and be reasonably confident it's somewhere on this little peninsula of land that the Thompson Point dorms are on. It looks like there's one fairly sharp corner on that peninsula. We're probably able to see that if we are somewhere on the south shore of Campus Lake, which we are. If you look at the south shore of Campus Lake and the Campus Lake path that's marked there, there is a small parking lot that we just walked by. You can't quite see it from here, but it's just out past that boardwalk over there and to the right of it. Okay? So we know we're somewhere on the south half of this map, but not exactly where. And again, the point of this exercise is to use the tools to put us on this map relative to things that are easy to spot elsewhere, the landmarks. If you have a lot of trouble in your brain sort of translating between this oblique or low angle view of Campus Lake, where we're down off of a right angle top-down view of it, you can literally hold your map kind of just below your sight line as you look out across this horizon and basically tip the map so that it's oriented to be horizontal where the lake water is horizontal. And the map will start to look like the landscape that you're looking at, okay? If you're sort of a little bit further along in terms of spatial awareness, spatial reasoning, your brain can sort of automatically translate between the top-down view in the shape of the lake versus the side-on or low angle or oblique view that your eyeballs see when you look out across the lake. Okay?
So is the top number the bottom number the azimuth?
The top number is the forward azimuth. That's the direction that you are aiming the compass.
Okay, so 10 degrees.
All right.
The bottom one's the back.
Bottom one is the back azimuth, plus or minus 180 degrees off of the bearing you just shot. Okay?
So wait, you subtract your minus 180 from the back azimuth?
So you subtract or add 180 to or from the azimuth, not the back azimuth. The back azimuth is the one that you get from that addition or subtraction. Good question.
Question for you.
Yeah.
So I have my degrees. Now, do I subtract 180 from like 15 degrees?
All right, so if your azimuth number is 180 degrees or less, you add 180 to that. You don't want to go negative,
Okay.
and you don't want to go above 360.
Well, that should equal the back azimuth.
Correct. So a 10-degree azimuth, 180 degrees off that is 190 degrees. If your azimuth is 270, well, if we add 180 to that, it's going to be over 360. So we'll subtract 180 from 270, and we'll get 90 as the back azimuth, or due east. Okay. So aim, no pun intended, for 3 or 4 separate landmarks. And then, if it helps, draw a little point right on the map where you believe that landmark is. So if you shot to a particular spot on Thompson Point, draw that point on Thompson Point with a little point right at the shoreline, if that's where you did it. All right. Remember, bare metal minimum of 3 to have any idea of how well you're doing. 4 or 5 is actually easier, and it's barely more work. This is just simple reading off of a compass and then adding or subtracting 180. On your map, go ahead and draw a little dot on top of each one of those landmarks, as precisely as right on top of that landmark as you can. And then your next step is to use your compass or your understanding of a compass rose, just the directions that each of those degree back azimuth measurements point. 0 is north, 90 is east, 180 is south, 270 is west, and so forth. And draw a line from that point of the landmark in the direction of the back azimuth. So if one of your landmarks is a particular spot on Thompson Point, let's say it's the back azimuth is 190 degrees. Just making up some numbers. Put your pencil on top of that point and draw a very straight line in the direction of 190 degrees, assuming that 0 degrees is up on your map in landscape view. So 190 degrees is very slightly west of south. So mostly downward, slightly left on your map. And draw it right off the edge of the map. In that case, you're heading south, so off the south edge of the map. And you can tear out the scale bar page. I left a couple of blank pages in here so you can scribble some notes or, berate your elementary school math teachers or what have you. But use a folded over extra sheet of paper to draw a very, very straight line precisely from the point that you surveyed along the back azimuth from that point to where you are. You are theoretically somewhere along that line. So if you have at least two of those lines and they cross somewhere, that should be pretty close to where you are in real life. Now there's going to be a little bit of, wiggle on the pencil line. There's going to be a little bit of hand movement with the compass, so maybe it's a degree to either side of what the true measurement is. That's okay. So those two lines are not going to cross exactly precisely where we are. And that's all right, because we have a couple other measurements to triangulate off of, to double check our work. These lines should all generally cross in the same spot where you and I are standing. If they don't, then it's time to look at, do all of them but one agree? We're probably close to where the three agree. And the one is just drawn a little wrong, or that measurement, maybe you recorded the number while you were hiccuping, or whatever. Maybe you got shaky hands, no big deal. That's why we take 3, 4, 5 measurements, and pretty quickly we start zeroing in on where we actually are.
So wait, we take the degrees that we wrote down and we use that to draw the line?
Yeah, you use the back azimuth as the direction from the point to draw on the map. So let's say your back azimuth for one of your points is 190 degrees.
Yeah.
So if you were standing at that point, you'd look very southward, slightly westward, and you'd be looking at us. So you draw in the direction from that point, you draw a ray as it's called. So it's got an origin and a direction. And you draw very slightly west of south. Very slightly west of south for a 190 degree back azimuth. Because pure south would be 180 degrees. Numbers above 180 are toward the west. All right. It's okay if this is you, but is anybody figuring that your position is somewhere on Mars? This is just not happening right now.
Yeah.
I'm in the water.
Okay, that's pretty exciting. All right, so the main thing to do is double check your work, take some additional landmark measurements, and pretty soon it kind of starts working. All right, so I'll pull out a copy of this and do it as well, and you can follow along with me if you would like to. If you're already ahead of me, keep on keeping on. In the middle of the bench here. All right, so sitting here at the park bench, I can see there's a long limb of the lake straight back. It's a little bit hard to see because we're so low to the water. This is a little bit easier sometimes when you're up high on the side of a mountain. And I see that there's a long branch of the lake off to my left, which would be west. And we walked around the third and deepest sort of arm of the lake off to our right, or somewhat east-ish of us. We're somewhere down on the south edge of the lake. So I'm gonna pick, we'll say this kind of far away spot, kind of straight ahead, north-ish somewhere, right at the far end of this northward stretch of the lake. Let me borrow your pencil real quick. So I'm just gonna draw a point on my map at that landmark, and then holding the compass flat and steady, sighting with both eyes. That's what that is. All right, my forward azimuth is 326 degrees. So my point A, azimuth is 326 degrees. 326 minus 180 because I'm higher than 180 on my azimuth. And of course we always label our numbers because we're foresters. That's gonna be what? 146. We got the back azimuth right on there, but let's just calculate it properly. So 326 minus 180 equals 146 degrees. All right, so I can either continue taking measurements or plot this one on the map. So we start at the landmark, and then we plot the back azimuth as a ray from the point of its origin, the landmark, in the direction of the back azimuth. So 146 degrees is going to be slightly east of due south. That puts us, this is due south, east of due south is going to be somewhere over here-ish. All right, so 135 is going to be southeast, like that. So 146 would be about 10 degrees over from that. Something like that. All right. Make this line, just guessing it. If we have a protractor, if we're actually using the compass itself to orient the map and draw, gonna work like this. Put the compass, center it over the landmark point that you drew, and then find 140. So it's gonna be kind of like that. Okay. Second landmark. There's a boardwalk over there. All right, that's azimuth exactly 100 degrees to kind of the nearest rail. So our back azimuth, 100 degrees plus 180 is going to be a nice round 280. So I know that this is the dam and the wetland is kind of over here-ish in the green space. So it's going to be like here-ish somewhere. And our azimuth and back azimuth were 100 and 280. 100 degrees, 280 degrees. All right. I'm saying that I think my point is somewhere around here. That's not exactly right, but close enough. All right, my back azimuth is 280 degrees. Well, 270 degrees is due west. So this is gonna be slightly north of due west. So starting at B and drawing my line west, but slightly north of that. Gets me somewhere like this. Okay, so where these two initial lines cross, that's my estimate of where I am. And I have no idea if I'm anywhere close to that until I start looking at the map and saying, I mean, I'm pretty close to the shoreline. This is pretty close to the shoreline. This has me basically over in the wetland right over there, so this isn't exactly right. I didn't draw this exactly correctly, and that's okay. I just take a third measurement of some other landmark. So here it goes to the west and then comes back out in a point, and then it's got another arm that goes further west. That's got to be this right here. So I'm gonna shoot to this point right there where all those tall grasses are. We've got lake going past that to the south. We've got lake going past that sort of westward, but on the north side of it, that's here and here. So I'm gonna shoot to this point, C, and see what I get. Get it?
It's like a big range thing. Like that.
Okay, that's at exactly 300 degrees from here, so a back azimuth of 120. 300 minus 180, 120. 300, 120 degrees for the back azimuth. All right, so back to my map. Place my compass directly over point C. I twist my map so that it is agreeing with north, and then 120 is right there. My back azimuth was 120, so I draw from there in this direction here, like so. And as off happens, it's not super perfect, so now we have, instead of one place where lines cross, 3 of them. So I'm likely to be somewhere inside of this triangle. I can automatically throw away this point because it's on a road, and I'm not on a road. And just looking at the map and knowing how this path goes, I'm not really immediately on the path, so this point is not where I am. This is what's called a spurious result. This is your machinery or your instrumentation or your senses telling you something, but it's not necessarily correct. And it's because there's a little bit of error in this line getting aimed exactly where it is, a little bit of error in placing this point exactly where I looked, and so forth. So we keep adding more lines and see where the heaviest density of the crossing is. So how much of a problem is this much inaccuracy? I'm somewhere most likely on or inside this little triangle right here. And we're pretty zoomed in here, so it looks kind of like a big triangle. Have I failed in this exercise? Not really. I know which side of the lake on. I know I am east of a bunch of key features. I know I'm west of some key feature. We start narrowing down the box that we're in. And if you look at the scale bar, again, you can tear yours out if you want to. This will help us answer the questions in the back of the packet. So, I am actually right here. Okay, I'm most likely to be inside or on my triangle, but again, there's a little bit of error, and that's okay. So, my closest estimate was, let's see, this is 100 meters. I was less than 100 meters off. Not bad. From a wild guess of where I am on a topo map that covers all of Carbondale, all of campus, and some surrounding farmland and countryside. Okay? So, this is kind of slow and confusing the first time you do it, but remember, it's just take at least 3 sets of measurements, draw some lines in the opposite direction of those measurements, and see where they cross. A couple of minutes at most, and you get within 100 meters of where you think you are. Within 100 meters is probably close enough for government work if we're doing large-scale forestry stuff, cutting in a trail network, or surveying out some campsites, or monitoring some wildlife. Wildlife habitats for most species that we care about are mostly going to be a lot bigger than 100 meters on a side, except for some sessile species and stuff like that. Okay? So, we are truly here on the map. My estimates put us falsely on the road. We can rule that one out. And then within 100 meters of my closest point. Okay? Thank you for letting me borrow your pencil forever.
Yeah, you're good.
Okay?
So you're taking, like you're looking like this, basically?
Yep.
That's it from your angle. But okay. Sweet.
I just want
So I'm like under 100, obviously, on this one, but these ones are.
So when you are working as a patrol ranger in any of the big open western parks, and you've got good sight lines out to 100 miles or more, some of these landscape landmarks are going to be mountain peaks. And it's not ambiguous what or where that is on your map. And so you get to a point where it's not even worth bringing along the hassle and the not always perfectly waterproofed electronic GPS unit, because even as you're hiking down the trail, you just shoot a bearing to something that you see way off the way. You know which trail you're on because you know it by name. That's marked on the map. And the azimuth from a single landmark only intersects that trail in one place. I know where you are. And if you need any more sort of precise information on it, you'd stop hiking and take 2, 3, 4, 5 bearings and circle yourself on the map. Okay? So you combine this with your pace from forest measurements, and you know about how fast you're traveling after you get a little bit of experience traveling by foot or by pack mule or snow machine or whatever, and you get a sense of time with it. Like, I've been going for maybe 20 minutes, so I'm probably about here on the map. Oh, there's Mount Whitney, and it's about exactly where the map says it is, my estimate of it, just moving along this line on the trail. All right. So you kind of hone your sense of where are you going, how fast are you getting there, and so forth. And this kind of becomes second nature when you're out doing field work and stuff like that. Okay? Cool. For some jobs, when you're working out of a vehicle and you've got your, Google Maps plugged into your car charger the whole time, it's moot. It doesn't matter, right? It's faster to just fire up the app and so forth. But in a lot of places, your GPS can't work because you're in a canyon. And canyons provide lots of natural landmarks. But what they don't do is provide any access to the sky, especially if it's a deep slot canyon. You have no idea where you are unless you are tracking it yourself. And GPSs will never, by a basic constraint of physics, be able to shoot their signal through the walls of a canyon to get you any kind of an accurate signal. Okay? So this is a safety and life preservation skill. This is I need to find somebody to extract them because they've got their femur sticking out their leg and they're about to die kind of a skill. This is we are so deep in this thicket in this part of the forest that I can't get a GPS signal here. There's just too much canopy. There are lots of forests like that. Okay? Cool. So, this is the first step. Figuring out where you are on the map. This is called orienting yourself on the map. Placing yourself on it. Wayfinding as the extension set of skills past this. Once you know where you are, you can figure out where you're going. That's that set. Okay? So orientation is, where am I? or where is my target? And wayfinding is, how do I get there? Cool. All right, how's everybody feeling about this? Clear as mud? Super easy. Gosh, Park, just move on to the next thing. Where are we at? Pretty all right?
If I were to be graded on this, I'd be probably on the struggle bus.
Okay.
But that's just, I'm not a forestry major, so.
All right,
I'm more comfortable than I was at the beginning, so that helps.
that's a start. Yeah. Cool. So one thing that tends to throw folks relatively new to forestry fieldwork is overestimating how fast and how far you are traveling. And so this is a good reality check to make sure that your eyes are about the same size as your boot soles in terms of misunderestimating, as a former president once said, what the actual reality on the ground is in terms of your position and your status. Okay. All right, let's continue on. Got through that fairly quickly, so let's try again. Let's do another one. We'll start walking back the direction we came, and see if it works. All right, make sure we're not leaving anything behind. No wounded soldiers. Good. All right. Good deal. Excellent. And we'll fire up the laser hypsometer. That gives you compass direction rounded to the nearest degree, which is good enough for our purposes. On a proper surveying analog compass like these fluid damp Suntos, you can estimate down to a 1/10 of a degree accuracy very effectively. Okay. So in our mind's eye, let's pretend like we don't have any measurements from right over there. We don't quite know where we are on this map aside from somewhere on the southern half of it, which doesn't narrow us down at all enough to be effective. All right. So here we've got a different perspective on the same landscape, a different set potentially of landmarks for you to use. This parking lot is marked on your map. Okay, so you wouldn't shoot to the parking lot because that's a bunch of different measurements. You'd pick one spot that you're pretty sure is like one end or the other end of the lot as a single infinitesimally small point on the map and can only have one compass reading to it. All right, let's get after it. So take 3 or 4 measurements using the landmarks visible here. You can use one end or the other, which is very evident on your topographic map as the straight side of the lake, using that earthwork as a reference. And so forth. All right, so who wants to use one of the survey compasses? Anybody? Bueller? All right. Hold it flat just like this and look through that one. The big number on top is the direction you're looking. The smaller number on the bottom is the back azimuth that you'll actually plot.
Okay.
So if you plot 3 of these and you get kind of a triangle, a geographer would call it an epsilon band. That is the uncertain area in which you are very likely to find yourself. An epsilon band. If part of that epsilon band is out in the middle of the lake, you just ignore it because you can't be there right now. Okay? So, the tools will get you pretty darn close, within 100 meters, in my quick and dirty example, without even really plotting the proper direction of those rays. And you can also use deductive reasoning to understand that part of that epsilon band usually cannot exist. So for example, if you're standing on the rim of the Grand Canyon, you've got a bunch of landmarks and so forth, you plot those out, and within that space, part of that maybe triangle that you are supposedly in according to your map is back off of the rim on the Kaibab Plateau, or the Coconino Plateau, depending on which rim you're on. Part of that epsilon, that uncertain area in which you are most likely, is off down 1,000 feet inside the Grand Canyon. You rule that part out because you know you're standing up on the lip of the canyon, right at the edge somewhere. So you can real quickly, just by using some common sense, throw out a bunch of the uncertainty and kind of tighten up your estimate of where you are. All right? Now, at the top of the Grand Canyon, your GPS is going to work fine. Anywhere near those 1,000-foot cliffs, though, you're getting signal bounce and echo, called multipath error on your GPS. And it will put you way out in space off to the side because it's confused by those echoes it's getting from the satellites bouncing off of the canyon wall. It is notoriously difficult to GPS rock climbing sites as a recreation ranger because you're at the bottom of a big rock face and it's blocking half the sky and echoing everything it can see from the other half of the sky. So being able to plot this stuff on paper down to 100 meters or less, 10 meters or less, hugely valuable skill, will save you lots and lots and lots of time instead of waiting for the constellation of satellites to randomly reconfigure itself to be anything better than huge amounts of blocked or occluded sky and multipath error for the parts of the sky you can see. Okay? Cool. All right, so I think just looking at the map, I could use one or even both ends of the earthwork as one or two landmarks. They're kind of close to each other, so I can't rely on just those two to get a good, decent pair of crossing lines to show me where I am. But with that, way off in the other direction, now I'm looking along that long northern arm of the lake. I can shoot anything over there as a third. Either or both ends of our parking lot, which is marked on your map as a little sort of boxy loop on the road down there. That's a couple more. So we got 4 or 5 landmarks, a half dozen landmarks that are pretty quick and easy. They're pretty cheap to render, so to speak. It doesn't take a lot of thinking to pick those out and start plotting them on your map. So we don't live to survey this stuff. We're doing the surveying to live, to keep moving with our forest recreation work, whatever that is. For our purposes, we're figuring out where we are on the map so we can get our trail building crew to the right place quickly the first time and safely over the right terrain instead of taking them off a cliff and having to skirt around it and lose a bunch of time bushwhacking around cliffs, which are very slow going. Lots of loose rock typically. Remember, once you're done using any of the analog or the hypsometer compasses, pass them around to the next person so they can try it out. If we're doing this right, the type of your compass doesn't matter. It doesn't matter if it's your cell phone, which is good to about a degree. The analog compasses, again, accurate to about 1/10 of a degree. Laser hypsometers, magnetometer inside is good to about 1 degree. The particular tool shouldn't matter. It's the technique, it's the skill, and the reasoning behind it, the spatial awareness and spatial reasoning that puts you on the map with a functional degree of accuracy and safety fast enough in the context of changing weather. You got to figure out whether to seek shelter or continue evacuating or what have you. You don't want to spend a ton of time on this stuff. So you do it until you're pretty quick. Record the azimuth, add or subtract 180 to get the back azimuth, or read the back azimuth directly off of the survey compasses. Draw a ray starting from the landmark in the direction of the back azimuth. Rinse and repeat. See where all those lines tend to cross. Flip reinforced here. Who has a question? So far, so good?
Actually, yeah.
Once you kind of got that ground line up, it's pretty, not simple, but straightforward.
Yeah. It's luckily mostly idiot proof.
Yeah. Well, that's what I'm saying.
Usually the problem comes in one of two phases. You make just a simple math error, subtracting or adding 180 because it's not exactly like around 200, which would be nice, or around 100. And the other very understandable, normal problem is to just get a little bit sloppy drawing that 190 degree line instead of straight south at 180. Okay? All right, so let's take a look at the laser hypsometer and get a sense of how to use that for this. So this has a bunch of different functions built in. It's got a go button. All right, so you're in like Brazilian jiu-jitsu or something. This would be like the nerve cluster, like you press this and everything happens. And then it's got up and down arrows to select a mode. So you press it once to turn it on, and then you hold it up to your eye, and in the bottom right-hand corner, it's got the abbreviation for compass reading, azimuth, AZ. And then right in the middle, by the crosshairs of what you're aiming at, it'll put the 3-digit number. So for this side, the western side of this little parking lot over here, I'm going to sight just past those two parked vehicles. I look at it, it's on azimuth mode. Press the power / trigger / go button. It averages a bunch of measurements together because my hands are shaky. And I get 205.2 degrees. All right, so for anybody needing more measurements, there you go. 205 degrees azimuth, do that. So 25 degrees back at it. To the other side of the lot, 149.3. Okay? So there's about a 40-degree sweep from one end of the parking lot to the other. So one physical feature, the parking lot, gives us two measurements because it's kind of big inside of our field of vision. All right? We can use that to our advantage. You get a couple of measurements real quick. Would anybody like to use this? Super quick and easy. You just line up the crosshairs and press and hold button. Got it. It has a bunch of other functions, but we just care about the azimuth for today, the compass direction. All right, has anybody finished our second try? Show me what you got.
This is definitely the straight way. That's where the intersects. But I think we're a little bit more over this way.
That's correct.
But the straight way is definitely that way.
Yeah, so this B azimuth looks a little more like it, yeah.
Okay.
So you could plausibly say, yeah, I mean, this is only a difference of about 50 meters, maybe less, maybe 30, 40.
Okay.
Pretty close.
Solid.
Pretty close, man.
That's pretty close.
All right.
At about 50 meters, so my two lines crossed here, but that's the straight way right over there.
Yeah, I had mine a
and
little
I know, like more in this area.
Okay, so like here.
Yeah.
I mean,
Like he thinks like the B was pretty much on point.
so like right around here.
Yeah. I think that's what this is. I think this is the whole tongue here. If I understand
Oh, this is the little. Oh, okay. So
Then I'll run
yeah, it is. I'm ready for fall to be here.
I don't love the humidity, but like,
Summer camp sucks.
but like I prefer that over like center side. It's like
You like have to wear gloves inside buildings and outside.
yeah, I still like I wear sweatshirts like in classes to go there. Like I have a sweatshirt in my backpack because I wore it today.
There is a girl I worked with last night who was covered in pillows, and she was like, "No, can you hand me this marker? That's literally like 5 feet in front of her." I'm like, she's like, "I don't want to lose body heat. I'm sorry."
No, it's a real problem.
No, it is.
It really is. Like it seems really dumb. But yeah,
You're right.
I'll like my roommates will have the AC on and I'm freezing. I'll have like sweatpants and sweatshirts and then I like walk outside and it's like 90 degrees and I'm like
You're gonna feel that.
so like I don't mind this fall and spring when it's still like decently warm. It's when the fall turns more winter that I'm
All right, so Jack had a really good question. So on summer camp, we did basically a version of this without the instructions and stuff like that. And, you know, some of the folks had a little bit of difficulty resolving some of the landmarks that we had available to us, which is normal enough, right? You're not quite sure if that peak that you're looking at is this particular squiggle on the topo line, and so forth. You get better with it over time, just sort of interpreting what the shape of a particular peak looks like as topo lines versus as physical silhouette viewed from the side. So his question was, you know, what happens if you're just not real sure, maybe you can't find enough landmarks to localize yourself. Maybe you're off in the middle of the forest and your visibility is, you know, 50 yards or less and you just can't see anything big enough to show up on the map far enough away. But maybe you can see a single landmark through a break in the canopy and more or less be pretty sure that that's one mountain peak at least, and work off of that. So that's in the wayfinding equivalent or follow-on to this. If you know where you are on the map, it's easy to figure out how to go and get where you're getting. If you don't know where you are on the map, you can still try to generally figure out where you are or how to go to get somewhere, given that you have any sort of landmark present or available. And it works okay, but it's a slightly different reasoning, it's a slightly different approach, a slightly different set of things you're interrogating off of your map information that you've got. A third step from this would be to basically combine the needs of orientation with the functional abilities of navigation and use navigation to free up some more or get visible with some more points so you can figure out again where you are on the map. That's mostly used in survival situations or cross-country navigation situations where there is no trail. And so generally not at that level what we're going to be doing for day-to-day park ops and stuff like that. So we may not go that far in this class in terms of lab exercises, but finding yourself on the map, figuring out how to go, the wayfinding part of it, navigation, yeah, absolutely, for sure. Cool. Any questions about this? Okay. If you are still like way over in Indiana somewhere, according to your map, grab a compass, download a topo map onto your phone or tablet, or get paper ones. I find it easier on a paper map. Less stressful, it's not burning battery. Try it out. This is fairly simple math. So if this just is super confusing, go through it step by step. Okay, this does not lie to you. It's just super basic field measurements. This is hard to break unless you're making that plus or minus 180 math wrong, or just a little bit too quick and dirty on drawing those rays. Okay? That's about the only place this can break. Sound good? All right, let's head on back towards our meeting area, and we'll talk a little bit more about wildlife, springboarding off of last week's discussion about vegetation resources and all that relative to park management. All right, so on Wednesday of last week, we were talking a little bit about what it's like to manage vegetation resources. Your coastal redwoods, giant sequoia, state champion trees in Shawnee or what have you. We're at Mammoth Cave where we're going for a field trip in early November. And for wildlife, we're gonna kind of take everything that we've learned about vegetation resource management and how park visitors tend to trample that stuff, tend to graffiti that stuff, tend to try and take charismatic examples home, like wildflower picking, for example, in places that can't handle much wildflower picking. We're going to have all the same kind of human behavior dynamics, actions, motivations present with wildlife species as well, but it's going to be cranked up to 11. And we're going to add a factor in terms of how the wildlife respond to the human incursion. All right, so on Wednesday we were talking about how we want to pay attention to two R words, characteristic of each species we're trying to manage, each vegetation species. Something and something else. Resistance and resilience, good. Relative to the specific season that we're concerned with, and relative to humans wanting to be in that space at that time, trampling on, tree poaching burls, bringing wildflowers home, what have you, okay? Same thing is true with wildlife, except that they're mobile. And our recreation infrastructure, our roads, our campsites, our lodges, our water treatment facilities. Yellowstone had 1 million visitors in July this year. That's a lot of water that you got to treat to make sure everybody is not having uncontrollable explosive diarrhea like giardiasis or E. coli poisoning or anything. Okay? So, vegetation species, we can kind of carve up that habitat with roads, etc. With wildlife species, we really carve up that habitat with roads, etc. Okay? To the point that, the wildlife will start using our human transportation corridors in thicker wood or tundra environments as their transportation corridors. So I've been stuck behind a caribou walking down the road at Denali National Park for over an hour in our pickup truck because, well, if you're a caribou, a reindeer, it makes a lot of sense to use that road, which is piked up. It's elevated. It's clear of all that tundra. All those grizzly bears that are around them would love to, snack on reindeer kebab. The caribou's got a fighting chance. It's got a good sight line all around it, and it's a heck of a lot fewer calories for it to walk down that road with us stuck behind it, prevented by park regulations from disturbing the wildlife. It's a heck of a lot more sensible for that caribou to use that road than it is to be crashing through the underbrush, making a bunch of noise, being vulnerable to grizzly predation, or its young vulnerable to wolf predation or whatever up there in Alaska, okay? So, everything that's true in terms of human vegetation dynamics in parks, also true of wildlife, but the wildlife also respond, and they get impacted more by things like habitat fragmentation from putting in roads and campsites and stuff like that, just kind of willy-nilly before we really realized that wildlife biology, zoology, habitat management, before those disciplines really happened, we were cutting parks into the landscape. So Yellowstone formed in 1872. We don't have Aldo Leopold and A. Starker Leopold doing things like inventing wildlife biology and ecology and so forth until, 50, 60, 70 years later, depending on the particular innovation. So imagine a park being 3/4 of a century old, and it's got roads and lodges and stuff like that, and the wildlife have had to cope and adapt with that and cope with increasing visitor use over time as these places get more popular, as our population grows, as we add more roads and highways connecting parks to cities. There's a lot of history to kind of unwrap, a lot of historical damage or impact or suppression effects on population genetic quality, population sizes, population distributions across space, and so forth. One of the big problems at Yellowstone, after it was created, that was around the same time we were real busy fencing off the entire American West with barbed wire. And bison got cut off inside of Yosemite. They couldn't come down from the high wintertime plateau habitat that was way too cold, way too nutrient depleted for them to make it through. They were starving to death because they were just burning up all of their calorie storage trying to stay warm. And that was a function of creating a park. So that's kind of a fail. And we had to create Grand Teton National Park south of that in lower elevation down on the Snake River headwaters, and then connect those two by John D. Rockefeller Memorial Parkway Park so that the bison could migrate down and up every year. And we didn't do that until well after Yellowstone was created. Okay? So, wildlife management for parks in specific, we've got everything that the WAMCON and zoology specialization and major respectively have to say about keeping populations healthy and vigorous and well-fed with plenty of cover habitat and breeding and rearing, etc. habitat for basic life functions. And then we add 1 million people a year or per month, in some cases during peak season, on top of that. Let's head over to this picnic shelter and we'll finish up class over there. All right, so for the purposes of this class, we're going to treat human beings like just kind of a special wildlife species. So everything that we're talking about with respect to wildlife characteristics, wildlife habitat characteristics and needs and dynamics and so forth, after we finish talking about wildlife, we're going to apply all of that conversation to human beings, to visitors, and to park staff on site as well. And that's going to hopefully work out pretty well in terms of managing wildlife and managing wild people. So the main things we gotta keep in mind with wildlife is that wildlife, like humans, are going to be using all of these other layers of resource that we talk about this semester actively, like people do. Okay? Vegetation resources, they're going to be using the nearby watershed and the nearby airshed fairly passively. They're just going to kind of respond to changes that we put on the landscape as foresters, as park rangers, right? We burn through an area and the plants either get burned up and seed stock eventually depleted and go away, or they're adapted for that and they do a little bit better with fire on the landscape. Wildlife is going to change and move and respond much more actively, much more quickly than those plant communities are going to respond to the same wildland fire prescribed burn management action put on that landscape. Okay? So, one of the ways in which wildlife differs or supersets past what vegetation does in terms of rec management is how wildlife species respond to humans. Because humans are going to respond to wildlife and plant species with horror, revulsion, excitement, fear, depreciative behaviors like poaching some of the wildlife in the same way that they attempt to poach tree burls and sell that stuff to veneer factories and stuff like that. But the wildlife are going to respond to us, and they do that in a characteristic set of ways. So, when we go backpacking or we go hiking along a trail, the first thing that they're going to do is be alert to our presence. So, whitetail hunters, you are familiar with the signs of whitetail deer being aware of your presence. They're still doing whatever they were doing before you arrived, maybe feeding or covering their young or whatever. During the rut, maybe attempting to mate or whatever. And as people move into that space in a group or solo, imagine that's like a dose or a treatment or a stimulus to the wildlife. And from our perspective, we're just walking down the trail. But we enter their habitat or we move through their habitat, and all of a sudden they have a new variable that they got to track. So alert is the first behavior. They are paying attention to you, but they're mostly still doing whatever it was they were doing. When they are in alarm phase, they stop what they're doing so that they can more actively and cautiously monitor you. So if you're out in your tree stand or whatever, and you see the deer, rotate its ears towards you, but keep on feeding, that's alert. It's aware of you, but it's not changing what it's doing yet. Alarm is when that head comes up and those ears are swiveled towards you, and it's maybe finishing off the mouthful of food, maybe mast, that it's eating right now, but it's not feeding anymore. So for a lot of nutrient-limited species, and there are a lot of nutrient-limited species, stopping feeding is directly lowering the number of calories they can ingest and store as fat that season against a long winter. Predator and prey alike. Make sense? So alert's probably okay. They're probably not going to starve to death with that. If visitors are constantly pushing them into alarm behavior by coming a little bit closer, moving a little bit more aggressively, being a little bit louder, shaped more like a predator, for example, if your recreation mode of transport is a hang glider, that's shaped to a lot of wildlife species like a predatory bird, like a hawk. It's a triangular or delta shape, just like the spread wings of a bird with the head out front. Does that make sense? Okay, so that's the thing. We gotta keep in mind how we are being perceived by the wildlife. So there's alert, alarm. If there's sort of a low speed move away from you to go find cover habitat and stop feeding in the meantime, that can be either temporary displacement, which is probably mostly okay here in the temperate, well-watered Midwest. There's plenty of food available, there's plenty of habitat available other places if they move away from us. In nutrient-limited places, that displacement is a hard stop on feeding and protecting their young and so on and so forth. If there's a bird incubating eggs on a nest and we canoe too close, or we climb a nearby cliff for rock climbing or whatever, and we scare that bird off the nest, those eggs start cooling instantly. So even low-speed displacement at certain times of year, certain seasons, major catastrophic consequences for those organisms. Displacement means they can or short-term displacement, temporary displacement means they can come back. Long-term low-speed displacement means they leave and they don't come back. They just give up this territory to the recreationists. And most of the time, this is a little bit hard to spot unless we got good wildlife monitoring data on, they used to be here. There used to be an entire herd in this valley, and now we don't have a one, ever. Because we have a big lodge in the middle of this valley, and the elk are not able to use this valley safely anymore. So displacement is low speed, can be temporary or permanent. Either can be catastrophic for that local population. Evasion is high speed displacement. That's when you see the whitetail bounding off through the woods, crashing through brush. So not only are they losing feeding time or rearing time or mating time or, whatever, cover habitat time against predators, they are actively spending calories to get away from you. So this is kind of 2 scoops of raisins in a bad way against the survival of that wildlife. So alert, alarm, temporary or permanent displacement, evasion, and from there, if the human presence continues to ramp up, get closer, a bigger group, a more aggressively acting or louder group, or more threatening perceived by the wildlife group, then we get into things like charges. So charging is an aggression response. It's either a bluff charge, where they are running up and roaring in your face, or rearing up and bugling to try and scare you off, but they'll typically stop short. I mean, they'll stop like 6 inches from you, and it's terrifying, and you got to change your pants afterwards. But bluff charges are most commonly what happens. They make for really exciting and unfortunate Instagram videos. Actual charges, so like aggression charges, that's when the grizzly bear, because you've cornered it or because you are in between the bear and its young, it's not trying to scare you off, it's removing the problem and your head with a swipe, So charges can happen one of 2 ways. The third way that looks like a charge but is not is food attraction behavior. So that tends to be lower speed, tends to be much more tentative. It can be with large or small wildlife. That is, somebody's fed that animal in the past, and our sugar-dense, calorie-dense, nutrient-dense, artificially flavored with chemicals called excitotoxins, which are like the neon green of artificial flavorings, excitotoxins. They taste really good, and you can get the same nutrition value from a single campsite and flipping over their cooler and eating their sausage links and their pancake mix and their power bars and all that stuff, and maybe the wrappers too, and obstructing the gut to the point of them dying from it. As they get like a week foraging soap berries in tundra washes up in Alaska, stream beds up in Alaska. So it's pretty easy calculus once the animal figures out, man, these humans aren't necessarily themselves tasty, but they sure do bring a lot of food, and they call a lot of attention to themselves by smelling really good and grilling out, and I'll just kind of peruse around this campsite, maybe make a little bit of noise. They'll all freak out and run back to their car and grab their phones and go, Harold, look, it's the bear, get my phone. And I'll just kind of roll through their campsite, eat everything, and then just roll through the next campsite and do the same thing. So food-attracted bears, fed bear is a dead bear, you see. Slogans like that, do not feed the wildlife, and so forth. Rodents explode in population density around campgrounds and campsites. And then everything that predates those rodents, mice, rats, ground squirrels, whatever, everything that predates those also later explodes in population density. So where you put in a campground, expect to have mouse-dropping mediated diseases like hantavirus killing off your visitors every once in a while if you're not getting a hard killing frost to kill off that virus every winter. In tent cities at Yosemite in the valley, this is a thing. People started dying from that, and they couldn't figure out why. Turns out it was just mice infesting the permanent canvas hard-sided tents, kind of over and over, and then their poop would dry up, and you throw down your sleeping bag, the dust puffs up around it, you breathe some of that in and get the hantavirus, and you drown in your own lungs. Kind of a COVID-style way to go, but very, very tightly tied to specific recreation spots. That's the thing. So in backcountry cabins and sheds and work sites and stuff like that in a lot of national forests and parks, if it's not cleaned out, if it's not maintained, if it's not heated through or left to freeze through the winter, like it's a heated facility and there are mice inside, this does kill like grad students and foresters and park rangers not every year, but every once in a while, and it's like, oh, well, we got a mouse problem. Somebody just died of hantavirus. It's a pretty acute onset thing. It's hard to fix. It's hard to pull the person back from the brink once they get that, okay? So that's a function of people being sloppy with crumbs. And that's a function of us going into a forested or otherwise natural park habitat, bringing in a bunch of resources and changing the behavioral response of everything up from a grizzly bear down to the lowliest little mice, and impacting their populations, and then in return impacting our populations, either from somebody tries to defend their cooler from a bear that is food attracted, and the bear takes a swipe at them, and they get all sorts of puncture wounds. It'd be like up in the 2 or 3d6 slashing range for those of you 5e players. Pretty nasty stuff, and so forth. The last and only good behavioral adaptive response from wildlife to your visitors is going to be habituation. That is, people are not feeding them, people are not threatening them or driving them off of their functional home ranges for feeding, rearing, breeding, cover, etc. And they become acclimated to human presence as just another wildlife species that's unremarkable. Like caribou don't particularly care much one way or the other about ravens, for example, in the same habitats like at Rocky Mountain National Park. But they do, done wrong, care a lot about the humans present. And over time, over generations, over lots and lots and lots of coaching and visitor contact and putting signs out and enriching habitat away from human travel corridors, you get populations that are much less affected by people. So this is the only good outcome. This is the only good timeline following the snappening. All right? We get a lot of wildlife species are more sensitive than people realize. So elk, for example, charismatic megafauna. They're big, they're warm-blooded, they're fuzzy, they got antlers, they have cool-sounding calls during mating season and stuff like that. Charismatic megafauna. Like, people go to parks to see elk. People go outside of parks to the national forest around them to shoot elk. Charismatic megafauna. Elk is delicious. For all of you non-vegans out there. Elk have a flight radius. They will start displacing if you are within 1 mile of them in the wild. And that doesn't leave a lot of space left over separate from that elk habitat plus a 1 mile buffer around it to put people in parks and forests, stuff like that, and do backpacking and recreation. So if you can kind of thread the needle of having backpackers moving through elk territory, understanding that at first you're going to be displacing the elk off their feeding habitat and stuff like that in the summer when backpacking is popular. But after a while, that herd's going to become used to it, and they're going to temporarily displace. They'll come back to that feeding, rearing, mating, cover habitat, and so forth, and carry on about their business. And the backpackers ideally go through and carry on about their business. Maybe they get a cool photo from a long distance away. If they angle towards the elk on a direct approach line, that's a very threatening, predator-like human behavior. And so the elk are going to respond to that. They're either going to go away, or maybe a bull elk, especially during the rut, is going to straight line approach the approaching person and F their S up, okay? They're going to say, cache these antlers, and it's going to turn into a confrontation, all right? So, alert, alarm, evasion, displacement, short-term or permanent, charges, either bluff or actual aggression charge, food attraction behavior, or, ideally, habituation. Make sense? All right, cool. Let's end it right there. I think we're about out of time anyway, and let's start rolling back. We got about 10 minutes, so get you back on campus. I'm around for questions if you have them. If you have stuff, bring it on over like Alyssa. Awesome, thank you. Awesome, thank you. So let me lose that for you.